So we're going to continue on in Unit 1, and we're going to discuss density. We previously had discussed measurements and prefix multipliers. So we're going to discuss density and talk about how to solve problems involving density. So density is equal to mass divided by volume. A lot of us use density every day and don't even think about it. For instance, if I ask you, I have two boxes that are of equal volume, and I say one contains tons of old chemistry textbooks that are very heavy, and the other one contains very light feathers, but they're the same volume. And I don't care which one you carry, just as long as you could carry one. So, when I ask this to students in class, they always say, I carry the one filled with old chemistry textbooks because I want to help you out, with a wink and hoping they get a better grade because of that. But the reality is a lot of us would choose feathers. Not as much work. We're trying to save energy, right? So it turns out, since these two boxes have the same volume, but they have different masses, the one with feathers, since it has less mass, is going to have lower mass, same volume, so it's going to have a lower density, so it's going to be less dense. The one filled with chemistry textbooks is going to have a higher density or a larger density, so it would be a lot more difficult to carry. So I will ask you questions involving density, and the most challenging aspect students face with density is identifying the units. So units of mass can have grams or milligrams or kilograms. Units of volume, you'll usually see liters, milliliters, or cubic centimeters. So your density can have units of either grams per milliliter, grams per centimeter cubed. The most common units you see on density would be grams per milliliter or grams per cubic centimeter. Now, when you're asked to calculate the density, it can be a pretty straightforward question. A lot of students will make it more difficult than it needs to be, but I always teach students, and this especially applies to this class, the density triangle. So DMV. Where do you go to get your driver's license renewed or pay, get new tags? You go to the DMV. So the way this triangle works, you cover up what you're trying to solve for. So in this case, if you look at this first question, a sample of salt water has a mass of 6.25 grams and a volume of 5 milliliters. What is the density? So density is going to be mass over volume. So I would say density equals mass over volume, and I would plug in 6.25 grams, divide that by 5 milliliters, and use my calculator. So 6.25 divided by 5, 1.25 grams per milliliter. Okay. Another type of question you could see, a piece of lead has a volume of 12.5 milliliters. The density of lead is 11.4 grams per milliliter. What is the mass in grams of the piece of lead? Okay, so you use the same density triangle. You cover up the M. So you're going to say M equals density times volume. So it's 11.4 grams over 1 milliliter times 12.5 milliliters. Milliliters cancel out. So 11.4 times 12.5, you get 142.5 grams. And in higher level chemistry classes, we learn about significant figures, but for this course, we don't worry about significant figures. So this answer is perfectly appropriate. Okay, the last one. A piece of aluminum has a mass of 6.75 grams. The density of aluminum is 2.70 grams per milliliter. What is the volume in milliliters of the piece of aluminum? Okay, so you cover up the V, and V is going to equal M over D, so that's mass divided by density. 6.75 grams divided by 2.70 grams per milliliters. And if you're wondering what to do with your units, when you divide by a fraction, it's the same as multiplying by the reciprocal. So if you take this portion of your denominator, or the bottom, and you flip it, your grams cancels out. And I'll just eliminate that, and you get milliliters. So 6.75 divided by 2.7, 2.5, and I'll put a 0 after this. You don't have to. Again, we're not getting into significant figures, but that's how you come up with your answers. If you look on the next page, I have several practice problems, and a lot of them, the first one asks for density, second one asks for density, next the third one asks for grams, the fourth one asks for grams, so that would be mass, fifth one asks for volume, sixth one asks for volume. So I want you to try and take some time and work these problems. So you can hit pause right now. You're going to be using the density triangle. And I will caution you with this density triangle. I've had, when I first started teaching, I was not wise in the ways of the density triangle. I didn't realize how much it helped students. So I would teach a complicated method and students would still struggle with density. Then one of my students had gone to the SRC and they'd gotten help from a tutor, and the tutor said, "You've got to use the density triangle, use the density triangle." So one day the student came to class and she showed me the density triangle. She's like, "I love it. It makes so much more sense. I'm going to use the density triangle." And I said, "Good, you go for it. I'm glad you understand it better." Well, when she took the exam, she filled out her density triangle incorrectly. So she had M and D switched instead of having D and V. So all her answers were incorrect because it was not the right algebraic manipulation of the original equation. So she was so disappointed to learn that she'd missed a lot of the problems because she was so excited about this density problem, or this density triangle. So I caution you when using this density triangle, please, please, please make sure you have it filled in. DMV. That makes it easier to think for all my music people. Okay, so hit pause, try to set these up, and then I'll go over the answers in a minute. Okay, so for the first question, you were asked to solve for density. So D equals M over V. You plug in 36.4 grams, and you plug in the volume, so you get 0.798 grams per milliliter. So you're dividing these in your calculator. The next question also asks for density, so you're plugging in mass and volume. So you get 0.746 grams per milliliter. And if you're getting thrown off on how many, if you're recording more digits than I am, that's completely fine too. We don't cover significant figures in this course, so you won't get counted off. Question 3, mass equals density times volume. You're asked for mass, so you plug in the density, multiply it by the volume, and you come out with grams. Same thing for question 4, you're asked for mass, so it's density times volume, and you end up 0.971 grams per milliliter times 3,800 milliliters gives you 3,689.8 milliliters. Number 5, you're asked for volume, and if you look at the density triangle, you cover up volume. Volume is mass over density, so you plug in your mass, divide it by your density, and you come up with 31.6 milliliters. And the last question is also asking you to solve for volume, mass divided by density, so 1180 divided by 1.8, and you end up with 656 milliliters. And again, if the number of digits that you record is off from me, but you have the same rough quantity, then you're okay. On the exam, it will be multiple choice, and on the quiz that covers density, it will be multiple choice as well. Okay, so that's density. If you're not quite getting it yet, practice your density triangle, practice the homework problems that pertain to density. Practice, practice, practice. Make sure you ask for help before the exam. So the SRC, my office hours, the Academic Achievement Center, you can email me, lots of different ways. The main thing is doing your work and getting help before it's too late. Okay, so on the next page, we cover energy. So energy is the ability to do work. Potential energy is stored energy. It can be gravitational or electrical, etc. So chemicals contain potential energy due to the chemical bonds holding the atoms together. When you eat, your body breaks down chemical bonds to release energy. So chemicals contain, and I'm going to put PE, body converts them to energy. That makes you be able to run, exercise, whatever you might be doing. Kinetic energy is the energy of motion. The faster an object is moving or the heavier it is, the more kinetic energy it has. So there are many different units for measuring energy. A common unit is the calorie, which is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. So a food calorie is different. A food calorie is equal to 1,000 calories. So 1 calorie let me write this differently. 1,000 calories is equal to 1 big calorie. Okay. Okay, so heat is the energy which moves from a hot object to a cold object. Okay, so two objects can have the same temperature but a different amount of heat. A cup of water at 100 degrees Celsius has much less heat than a bathtub full of water at 100 degrees Celsius. The bathtub has more water, so it contains more heat, even though both the bathtub and the cup are at the same temperature. Conversely, two objects can have the same heat but different temperatures. A cup of coffee might have a certain amount of heat, which might raise its temperature from room temperature up to 80 degrees Celsius. If the same heat were placed in a large body of water, like a swimming pool, it would raise the temperature very little, as the heat energy would have to be distributed over a much larger number of molecules of water. Okay, so moving on. We're going to talk about the structure of atoms. So we're going to shift gears and talk about what elements are made up of. So if you had an excellent pair of scissors to cut a piece of aluminum foil and kept cutting it in half, would you reach a point where you couldn't cut it any smaller? And the answer is yes. You would reach the atom. So the smallest piece of an element is called an atom. And I want to clarify that. When you have your scissors and you're cutting this aluminum foil, and these are the best pair of scissors possible, and you get to the point where you cut them and you cut them and you get to the tiniest point which you've reached the atom, and you can still distinguish that this is an atom of aluminum versus magnesium versus fluorine. So you can still distinguish that it's from that element. So I just want to make that clear, that you can still distinguish it from other elements, even though you've gotten to the tiniest building block. Okay, so Aristotle believed that matter was continuous. He didn't believe that there were atoms, and that all matter was made of earth, air, fire, and water in various combinations. Because he was considered an authority, people accepted this view for thousands of years without question or experiment. Aristotle also believed that one substance could be transformed into another. Much of medieval chemistry, called alchemy, was an attempt to convert lead to gold or find an immortality potion. So John Dalton is generally given credit for the modern idea of the atom. Dalton proposed the atomic theory, which is a model used to explain the behavior of elements in chemical reactions. So, this atomic theory that John Dalton proposed states that all matter is made of very small particles called atoms. So all matter is made of atoms. The next part of this theory, a chemical reaction involves the rearrangement of atoms. Atoms cannot be created or destroyed. So this is rearrangement. Okay. Let me say one more thing about this. Atoms can be destroyed in nuclear reactions, but not in chemical reactions. We'll talk about nuclear reactions later on. They're pretty neat. Okay, so all atoms of a given element are the same. Atoms of different elements are different. So all atoms of a given element are the same. Atoms of different elements are different. Okay, compounds are formed when atoms. Oh, wait, I forgot one thing. So isotopes, we'll talk about isotopes too. All atoms of a given element are the same. Atoms of different elements are different. This has kind of been modified with the discovery of isotopes. So we'll cover that coming up, but it's not a big deal at all. It's just kind of how we were discussing in the first lecture, how with theories you kind of have to be flexible based on what you have observed. So this theory is tentative. Once they learned about isotopes, said, wait a second, this theory still holds true. It's just a little bit more flexible within the regard of isotopes. Okay, compounds are formed when atoms of different elements combine in fixed proportions. Compounds are formed when atoms of different elements combine in fixed proportions. Okay. Last thing in the atomic theory, atoms of different elements have different masses. Okay, so that is the atomic theory that Dalton proposed. Just a little side note about Dalton. Dalton was a Quaker and a very modest man. He is also said to have been rather cold and humorless. He spent his life accumulating experimental data, including observations of weather and rainfall each day. He discovered he was colorblind when he bought fabric for his mother's birthday, which he thought was gray, but which was actually red, and unacceptable for a Quaker. Red-green colorblindness is still called Daltonism. So if you ever come across that in a biology class, you can think of Dalton. Okay, and the last part of this lecture covers subatomic particles. So the atom is made of smaller subatomic particles, the proton, neutron, and electron. The atom consists of a very small nucleus with electrons orbiting much further away. So most of the atom is empty space. Okay, so I'm just going to go through. So you have the nucleus, and then you have the electrons orbiting that nucleus, and in the nucleus you have the protons and the neutrons. So the electron has a -1 charge. It's outside the nucleus, and it has negligible mass. So the nucleus contains protons and neutrons. The proton has a charge of +1. It is in the nucleus. It has mass 1 AMU, 1 atomic mass unit. The neutron has no charge in the nucleus as well, and it has a mass, I keep doing this, has mass of 1 AMU. Okay, so the electron was discovered through experiments on electricity. It showed that it was made of small negatively charged particles, originally called cathode ray particles, after the name of the experimental equipment, but now they're called electrons. So J.J. Thomson experimented with electrons, measuring their deflection in a magnetic field. And so these are the ones that orbit the nucleus, and determined their charge to mass ratio. Most scientists at the time did not believe electrons were particles, so Thomson is given credit for the discovery of the electron. And then Robert Millikan, determined the charge of an electron through experiment. He observed drops of oil which picked up charges in an electric field and determined the gravitational force on the drops. By balancing this gravitational force with an electric field, he was able to determine the charge of an electron. So what these scientists did was remarkable because they lived a long time ago and they learned so much with so little. Think about all the technology that we have now. It's amazing. So I'm going to put Thomson, J.J. Thomson, and Millikan. Okay, the nucleus, Rutherford worked on this. Ernest Rutherford carried out an experiment designed to determine the structure of the atom. He shot alpha particles, which are small positively charged particles, at a thin piece of gold. Most of the alpha particles passed through the foil, but some were strongly deflected. This indicated that the atom had a small positive charge with electrons orbiting at a great distance from it. The small positive nucleus caused the large deflection of the positive alpha particles. So this was Rutherford. Discovered the nucleus. Okay, the proton. Goldstein discovered the existence of positive particles in the atom. And then the neutron, J. Chadwick discovered the existence of the neutron in 1932. Okay, so to review, the electron has a -1 charge, 0 mass, and it's located outside the nucleus. The proton has a +1 charge. It has a mass of 1 AMU, and it's located in the nucleus. The neutron has a 0 charge, a mass of 1 AMU, and it's located in the nucleus. So be sure, we got a lot of information from this lecture. Be sure that you study it, do your homework problems pertaining to it, take the appropriate quizzes, and ask for help if needed. So until next time.